Hi, my name is Trevor and welcome to this video about automatic search algorithms in GeoStudio 2D. First, we will go over the different algorithms available and then we will see their application in GeoStudio. Automatic search algorithms are computational methods that use an iterative approach to determine an optimal solution. For stability analyses, the optimal solution you are looking for is the slip surface that has the lowest factor of safety. These algorithms can be used to determine both the location and the shape of the sliding mass with the lowest factor of safety. The general procedure employed by automatic search algorithms is illustrated here. First, the range of parameters that we are searching for must be defined, ultimately to set the bounds of the search. Then, an initial population of solutions are generated, which are slip surfaces in a stability analysis. Given the initial solutions that were produced, we assess each solution using a predefined objective function. In the case of a stability analysis, this would be the factor of safety associated with each slip surface. The solutions, or slip surfaces, are sorted according to the results from the objective function calculation. The algorithm then enters the iterative portion, where the worst solutions are removed, new potential solutions are generated, and these new solutions are assessed and sorted. The worst solution in our stability analyses are the ones with the highest factor of safety. New solutions can be generated by different methods, including cuckoo search, particle swarm optimization, and differential evolution, which are all different types of optimization algorithms. The iterative process continues until an ideal solution is reached given the original bounds set at the beginning of the procedure. Once this solution is reached, the process ends. The three optimization algorithms mentioned here, cuckoo search, particle swarm, and differential evolution, are available in GeoStudio. Let us go through each of these in more detail to better understand how they search for the slip surfaces with the lowest factor of safety. Cuckoo search, inspired by the brood parasitism of cuckoo birds, starts with a population of host nests, which each represent a potential solution. These are randomly generated within the search space. It improves solutions by generating new candidates through levy flights, which enable long-range exploration, and by selectively replacing less fit solutions in the population, thus maintaining an effective search balance. Particle swarm optimization improves solutions by mimicking the social behavior of swarms, where each agent adjusts its position in the search space based on its own experience and that of its neighbors, striking a balance between exploration and exploitation. Differential evolution evolves solutions by combining the differences between randomly selected individuals in the population to generate new candidate solutions, promoting diversity and guiding the search toward the global minimum. The automatic search algorithms are used to define both the shape and location of slip surfaces in both 2D and 3D analyses. In 2D, there are three options for the slip surface shape generated by the search algorithms. Previously, GeoStudio only searched for circular slip surfaces, but now the automatic search algorithms can also produce slip surfaces defined by polylines and splines. You can learn more about each of these algorithms by watching our webinar that goes into more detail about them. Now I will show you how to set up the automatic search algorithms in GeoStudio. First, go to Define Project. Then, click on the Slip Surface tab. Click on the Search Method drop-down and select Automatic Search. Click on the Algorithm Type drop-down and select the algorithm you want. In this case, I will use Particle Swarm Optimization. The number of agents is the size of the initial population of trial slip surfaces, and the number of generations is the number of times a new generation of solutions is reproduced. These multiplied together come up with the number of trials. The default parameters are generally acceptable for most problems, but may need to be adjusted if the generated slip surfaces do not adequately cover the search area. The distribution of slip surfaces over the domain can be visualized via a slip surface color map. Underneath the number of trials, you can select your shape, which I will select circular. And finally, you select your direction of movement, which I will select left to right since my slope goes down from left to right. Now I click Close. Now let us review the results of each algorithm. Here we can tell in the results that the algorithm searched across the entire domain. As we go through the results, we can see different combinations of algorithms and slip surface shapes can result in the lowest factor of safety, which shows the importance of testing different combinations. Thank you for watching today.